I would like to wish a very good day to Dr. Jessie. I'm Carmen, so I'll continue to explain the experiment set 4, which is varying training sample size. This experiment investigates whether increasing the amount of training data can improve the predictive performance of machine learning models. So from the previous 3 experiment sets, we selected the 3 best performing models, which is support vector machine with information gain top 7 features, and also random forest. Their optimal hyperparameters were retained so that any performance differences observed in these experiments were solely due to changes in training sample size. The models were trained using cumulative training subsets from 10% to 100% of the training data, increasing in 10% of increments. After each training stage, the models were evaluated using the same independent test set, consisting of 9,043 samples to ensure a fair comparison. Since the bank marketing dataset is imbalanced, F1 score was selected as a primary evaluation metric because it provides a balanced measure of precision and recall. So before varying the training sample size, we first identify the 3 best performing models from the previous experiments. The first model is support vector machine using all 26 features with an RBF kernel. And the second model is SVM combined with information gain feature selection, which retain the 7 most informative features. And the third model is random forest using all features with an estimator of 300 and balanced class weighting. Among these models, random forest achieved the highest baseline F1 score of 0.5880, followed by SVM with information gain at 0.5814, while the original SVM obtained 0.5580. So these 3 models were then selected as the baseline models for evaluating the effect of different training sample sizes. So this slide presents the F1 score obtained by the 3 selected models as the training sample size increased from 10% to 100%. Random forest consistently achieved the highest F1 score throughout the experiment. Its performance improved from 0.5358 using the 10% of the training data to a peak of 0.5910 when trained with 90% of the data. Even when the full training dataset was used, the F1 score remained stable at 0.5878, indicating its strong generalizations. So the SVM with information gain also consistently outperformed the original SVM at every training size. This demonstrates that selecting the most informative features improved the classification performance while reducing the feature dimensionality. So overall, increasing the amount of training data improved the performance of all 3 models, with random forest showing the strongest predictive capability. This slide summarizes the overall improvement achieved by each model from 10% to 100% of the training data. The random forest recorded the largest improvement with an absolute F1 score gain of 0.0520, representing a 9.70% of relative improvement. The SVM with information gain achieved a moderate improvement of 0.0196, while the original SVM showed the smallest improvement of 0.0139. So this result indicates that random forest is able to utilize additional training data more effectively than the 2 SVM-based models. In addition, the improvement achieved by SVM with information gain confirms that feature selection contributes positively to classification performance. So in conclusion, this experiment demonstrates that increasing the amount of training data generally improves the predictive performance of all evaluated models. Among these 3 models, random forest consistently achieved the highest F1 score and exhibited the greatest performance improvement as additional training data become available. This confirms that ensemble learning is more effective than the individual SVM models for the bank marketing classification task. Based on these findings, random forest is recommended as the final module due to its superior predictive performance and robust generalization capability. For future work, model performance may be further enhanced by exploring advanced ensemble techniques, hybrid learning approaches, or traditional feature engineering, rather than relying solely on increasing the amount of training data. Thank you. This is my presentation for experiment set 4.